Good morning. This is Fluid Mechanics Project 1, Dr. Ozbay. I'm Joey. My part for this project is just the Couette flow, so just part B. Go ahead and share my screen here. There we go. All right, so and just we're gonna go ahead and well, that's okay. I'm gonna go ahead and start a new little thing here. We're gonna right click on geometry, or the design monolith, and take a second to start up. There we go. All right, go normal to the z-axis. Go to sketching. Actually, first things first, gotta change our units from meters to millimeters. It's not completely necessary. I'm gonna draw a rectangle and then give it some dimensions. So it's gonna be vertical dimension between the top and the bottom, and a horizontal dimension between the left. Once you make those dimensions, they'll come down here. I'm gonna go ahead and do 10 millimeters by 1500. Yes, by 1500. That's just because in our project, it said that the length has to be 150 times the height. So now that we have that, we're going to go concept surface from sketches. I'm going to change my select method here. Box select. Get selected. Oh, shoot. Apply. Generate. And now we got ourselves a surface. And that's that. There should be a green check mark, which there is right here. So now I don't really need that. I won't close it out just in case. That would go to our meshing. This is gonna take a minute. Not totally. Here it comes. All right, here we are. Again, gonna go normal to the z-axis. First things first, I like to label all of the edges. So up here, this top banner, you got all your zoom options, whatever, and then you kind of have all these select methods. It's like full bodies. It's sort of like when you know how it snaps to this edge, you can choose what you want to snap to. So I can choose facing, and then I'll select this whole face when I hover over anything. We want the edges. So I'm going to start a label the inlet. So you can click it once it's green, it's selected. I can right click anywhere to do create name selection. Out of that. Not that one. Here we go. Create name selection. Now, if I go to the left, this looks pretty here. See, inlet, outlet, top wall, bottom wall. Perfect. Now we need a mesh. So what we're gonna do first is go up here to mesh, right click on it, go insert, and then insert a method. We're gonna select our face here, and then go to geometry. We're gonna click that, and we're gonna click apply. And then once that turns purple, you're gonna press generate. Okay, that should be good. We can check that by clicking that here. You'll see there's some lines. And then next, we're going to do our inlet to outlet mesh. So, right click on mesh, press insert. Now it's going to be sizing. Read about it there. You see what's going on here? I'm selecting the face. So I got to go back up here, go to edge actually, and now don't select. Now I'm going to do control select so I can have them both selected. So now you can see they're both green. So that's all the geometry we're going to select. So we're going to press apply. And now we do not want to do this by element size. We're going to do it by number of divisions. So there's a drop down box, number of divisions. From this one, I'm going to go ahead and do 100. Yes. And then capture curvature, we're going to put on for now. And then change the behavior to hard. And that should be good. And press generate. Okay, sweet. I ignore this warning. Not completely sure what it is, to be honest. But things still work, so we'll go with it. And now, again, you can click mesh. This is our current mesh. It changed a little bit. We're going to insert another one. Insert sizing, right? So now we're going to do the whole top to bottom. So click, control, click, same thing, apply. Element size, nah. Number of divisions. But this time we're doing 1,000 divisions. And then capture curvature, nah. And then hard behavior. And we're going to generate this. This might take a little bit longer. Now, it's going to look black. You can see when you zoom in on a grid, but over here, it's funky. So now we're going to do a face mesh. So right click on mesh, insert, face meshing. Like that. You're going to want to select the whole service. So now let's see. This. Okay. Apply the geometry. And then this is going to be all good. So press generate. See what we're working with. Not black. You have to keep zooming in. Over here. Perfect. All right. So now we're done with the meshing. And go ahead, go back to workbench. And then there's no green check mark, but you can always right click and press update. See if there is one now. And there we go. All right, setup time. I'm gonna open setup. I think this is like the first part where we actually open Fluent. So you're going to press double precision. And then just because I want it to go a little faster, and I think my computer can maybe handle it, we're going to go for it. All right. So, oh wait, I don't think it's fully loaded. Way too soon on that. Okay. Now I think we might be good. Okay. So you recognize this, I'm sure. When you go to models, and make sure that the viscous is not whatever SSTK omega is. Press edit. I right click there. And there we are. And we're beginners there. So we're gonna make sure that's laminar, and then all the other ones are off. I'm not sure what they all mean yet, but we're learning. Our fluid is gonna be air. So I'm gonna right click this and press edit. I want to make my density just 1, and my viscosity is so this is Couette flow. I'm sure it'd probably be different if you're doing like Poisson or the combined condition, but since it's Couette, we'll get better results if the fluid's more viscous, or we can just see it better. I'm gonna do that for my viscous 0.01. Change and create, and then close. And then materials. So then we're gonna go into boundary conditions. Just gonna double click so I get it wrong. This is where things will change for each condition. Like I said, we're doing Couette. So I'm going to start with the inlet. Here we have the type is velocity inlet, and we want a pressure inlet because we have no input velocity for Couette flow. So gauge total pressure is 0 here, and that's fine. This all looks good. Slide and close, yeah. Bottom wall we'll check, just because it's up at the top. Type wall, edit. Stationary, which is what we want. No slip condition. Yes, sir. All right, that was good. And that we're gonna go to outlet. Pressure outlet is good. There's one thing we want to change here, and that is prevent reverse flow. I'm not sure if it would actually happen, but it just makes it look better when we actually have our graphs and calculations and whatnot. And then our top wall. This is the thing that's moving, so we're going to want to edit it. Moving wall. Speed, 10 meters a second. X direction, translational, no slip, perfect. Close. Okay, I think that is good for our boundary conditions. And we're going to go down to our reference values. You can notice too, like this whole left side, you're kind of just going from top to bottom, which is nice. For our reference values, it again will show us everything we got. Remember, I put density as 1, and here it's 1.225. So I don't really know why that happens. But when I go from compute from, and I press inlet, it goes to that density that I put in earlier. And then everything is going to be fine. But we're just going to make sure that we're going to do compute from inlet. And then now we're ready to initialize. So go to initialization, press initialize. There we go. Hybrid initialization is done. And then we're going to go to run calculation. The only thing I'm going to change is number of iterations. I'm going to make it like 100. Totally that up there. And then I'm going to press calculate. It'll take a minute. This is going to bring up the charts, I think. Show you. Oh, here we go. Yeah, this chart. Pretty graphs to look at. But you can see, oh, I'm pointing with my finger. You can see like this is the number that you're at. So I put in 100. So this number is going to keep going to 100. Then it's going to be done. So sit here and watch it. Getting there. Calculation completed. All right. Wait. So we got our scaled residuals and net. So now we're going to come up here to results. And we're going to press vectors. All right. And we're going to do new. Let's call this velocity vectors. Really original name. All right. Save. And close. Now, I got some colors. Oh, look at that. Looks familiar, doesn't it? Nice and linear profile. Zero velocity at the plate because of the no slip condition. Come on. Come on, linear profile, color flow. All right. So now we are good with the setup portion of it. So I'm going to go ahead and go back to Workbench. Now you're going to see setup, check mark, solution, also check mark as we did our calculation. So we're going to go to results now. There you go. This one never opens in full screen either. I don't know why. Got our model load in here. Oh, that. All right, first things first. You need two lines, one in the middle, one at the end. So we're going to go location up at the top here. That's lines. This one will be mid tank. And maybe let's call it mid line. I like it. All right, 2 points. So this whole thing is 1,500 millimeters, which is 1.5 meters. This is all going to be in meters. So we're going to do 750 meters. And same here. Point 2 is going to be 10 millimeters out, which is, I'm going to add a 0 on front. I don't know. And then samples, do 100 samples, not just 10. So 100 samples, press apply. If you did it right, you got a little yellow line right there in the middle. Okay, now we want another, our end line. So we're going to do another line. Line 1, no. End line. Okay. And now 2 points again. Now we're going to go 1.49. So 100 is away from the actual line, just because sometimes it gets a little funky at the end there. 1.49. 10 millimeters up. Samples, 100. Okay. That is good. Apply. And there's our little yellow line. So now that we have that, right, velocity contour. So this little rainbow contour up at the top, we're going to make one. we're going to call it. Yeah. Okay. My bad. I did not see this. Populate. Domains, all domains. Locations, bottom wall. We're going to go symmetry 1. Okay. Variable is not going to be pressure. It's going to be the velocity in the U direction or X direction. And then our range, range is going to be global. Number of contours. So if you do 11, that just means that there's going to be like 11 possible colors that it would show. We want it more of like a gradient sort of deal. I'm going to do 100 contours, and it should be a nice gradient supply. Okay, so here is our contour. This is like what we had before, but without vectors, just the colors. It always gets in the way. So you can go to your tree, yeah, and then go to legend, double click, just a variable, and then horizontal makes it go at the top. Just because these are kind of ugly to the 0, like just go appearance. I think that might say, but I just go, fix, and then apply, and now you can also change the size, make that large. This is just good to add in here, and then you can press Control and move around your model. So for my report, I'll just do that and take that snipping tool. It'll look good. So our velocity contour is made after you get the inlet. Kind of see the difference there because there's no plate right here, if that makes sense. So obviously this is all, it doesn't really like develop like Poisson, like how the boundary layers like will intersect, but you can see that this is a little different, and that's because there's no plate here and here to make it develop, I guess. Yeah. So now we have that. We need our velocity profiles at the 2 locations that we made. So we're just going to add in some charts. So up here, it looks like a chart. If this chart, it's a chart. Name, we're going to say velocity profiles. Okay. It's an XY line at this left side. XY line. Title. We might change that in a minute. Yeah, and then we're going to go to data series. So for 2 lines, we're going to have 2 series here. So at this right side of this little window, you can add, you can delete, and information. So we're going to have 2. So we're going to have 2 series. We're going to start with series 1, name it midline. And then we're going to kind of link series 1 with the location, so data source location. And these 2 are the names of the 2 lines that we created earlier. So midline and series 2. And line. Okay, our x-axis. It's not going to be the chart count. Our x-axis will be our velocity u. And then as you could, yes, our y-axis is y. We're going to see as y goes up, what is our velocity? And all this doesn't really matter, so I'm going to press y. It does matter, I'm sure. And just as you'd expect, so they're right on top of each other. But what you can do for your report, okay, actually, I'll circle back, but nice and linear velocity profile. That's what we expect for nice viscous Couette flow between 2 plates. So for your report, if you want 2 separate graphs, you can just delete the end line right here, and then press apply. And now you get just a midline. And then want to do it again, shoot, that should be fine. Here's 2, we go just like we did before, and line, and then its location through that, let's apply, and here we go, it's back. But yeah, that about sums it up. We have our nice velocity profile, we have our contour here. Oops, my bad. So yeah, you don't navigate, you create things up here. Navigation's kind of down here, so I can go table viewer if I was dealing with tables, and then 3D viewer will show my gradient or contour and chart views right here. Yeah, so that about sums it up. You can take, oh yeah, so for this, you're gonna want to do the screenshot like I showed you guys. Yeah, if you ever rotate, you press normal to the z-axis here. You can press control, and then move things up. It's gonna take your snipping tool in. For chart viewer, you can also do your screenshots with this, and like I said, change it around. But there's an export button right here, and that is for exporting things. I'll do it. Export file name, documents. Actually, I'll just show you. So yesterday I did this already. I went to documents, and then did the comma separated value, named it velocity profile. So now it just shows you guys the like this is for the midpoint velocity u at the corresponding y, and then if you scroll down, it'll be your endpoint. You have both of those to do it, because I think the project said you need to tabulate the data. So there you go. This is Couette flow case, and then my 2 group members will be doing the Poiso flow and then the combined Couette and Poiso flow. So yeah, thanks for watching. I hope I answered everything. Yeah.